Normalized field step. Normalized field pattern. Normalized field pattern. So, what is the definition of normalized field pattern? So, normalized field pattern is obtained by normalized field pattern is obtained by dividing the field component by its maximum value. Dividing the field component by its maximum value to obtain normalized field pattern. Okay, so for example, E of theta comma phi is there. Okay, so here, for example, E of theta comma phi, this value is, let us consider it is sine theta. So similarly, what is the value of E of theta comma phi maximum value? What is the value of sine theta maximum value? 1. Okay, so normalized field pattern. So normalized field pattern is represented with N. Okay, N of theta comma phi is equal. What is the expression? The expression is E of theta comma phi by E of theta comma phi max. So from this example, what is the value of En of theta comma phi? So it is E of theta comma phi is sine theta by what is the maximum value? 1 by 1, it is equal to sine theta. So normalized field pattern's value is sine theta. Okay, so I once again repeat what is the definition of normalized field pattern. The definition of normalized field pattern is it is obtained by dividing the it is obtained by dividing some maximum value, the field component by its maximum value. So this is the original field component dividing by its maximum value, we will get normalized field step. So this is the formula in terms of electrical field. If the field pattern is expressed in electrical field. So similarly, what is the formula for magnetical field? If it is expressed in magnetic field, if it is expressed in magnetical field, H1 of theta comma phi is equal to H of theta comma phi by same formula, H of theta comma phi max. Okay, so this is the formula if the field pattern is expressed in terms of magnetic field. The field pattern is expressed in terms of magnetic field. This is the formula if the field pattern is expressed in terms of electric field. If the field pattern is expressed in terms of electric field. Okay. So these are the formulas. Okay. So this is regarding field patterns. Okay. Similarly, the same thing we can do for normalized power pattern. So okay, we can do for normalized power pattern. So you see here what is meant by the normalized power pattern. So what is meant by this normalized power pattern? Normalized. Now we will discuss regarding normalized power pattern. Normalized power pattern. Now we will discuss regarding normalized power pattern. What is meant by this normalized power pattern? What is meant by this normalized power pattern? So here, what is the definition of ordinary power pattern? Power pattern means if the radiation is expressed in power per unit solid angle, such type of patterns are called as power patterns. What is meant by normalized power pattern? Here also the same. Okay, here also the same thing. P of theta comma phi normalized. Here n denotes normalized is equal to solid angle sum of theta comma phi by s of theta comma phi max. Okay, what is this s of theta comma phi? Theta comma solid you have expressed in terms of solid. What is the relationship between electrical field component and power pattern? It is square times. Okay, so we can express it as e square theta into theta comma phi plus e square phi into theta comma phi. So by z naught. So this is the value of s. This is the value of s. Okay, s of theta comma where z naught is the intrinsic impedance. Where z naught is the intrinsic impedance, it is equal to 120 by and S of theta comma pi max is equal to maximum value. Okay, so units are watts per meter square. Units are watts per meter square. Watts per. Okay, so this is the definition.